We're team7. Our product is called EcoSpin, Power on the Go. So imagine yourself as Jimmy. Let's call yourself Jimmy. You have an interview today at 12 o'clock, and you wake up at 11:30, a little bit tipsy and hungover because yesterday was your friend's 21st. And oh no, your cell phone battery is dying, and you need to go to your school, but you don't have a car, and you don't have time to charge your cell phone. So you don't have the convenience to charge your cell phone on the go. So what's missing in the world right now is power source to charge electronic devices and bicycles. Yes, there are some other devices that can generate electricity from bicycles, but some downsides of them are they can only be used for one application only. So let's say headlights, or they can only power one thing at a time and one specific thing. They can be very expensive. Some of them cost more than $100 to $400. And because it's very dependent on how fast you're pedaling your bicycle, there won't be a stable power supply, which can be detrimental to your electronic devices. So what is EcoSpin? EcoSpin is a bicycle attachment that can charge electronic devices which have USB compatibility, and it can also power headlight if you want to. This with little added effort by the user. So who wants EcoSpin? Our main target customers are bicycle enthusiasts, commuters, students, eco-conscious individuals. So in the case of Jimmy, he forgot to charge his phone overnight. He has to commute to school, and then he can just plug it into his EcoSpin, and voila, problem solved. So in developing our designs and concepts, here are some objectives and requirements that we need to satisfy. So the first ones are the quantifiable requirements, which is it should be lightweight, it should be compact, it should provide a stable power supply because you don't want to harm your electronic devices. It should be efficient in the energy conversion. It should be versatile in terms of you can charge your cell phone, you can charge your iPod, you can charge your digital camera. Some non-quantifiable requirements are it should be safe for the user, so no electric shocks. It should be easily installed. It should be lockable so that people can't steal them. It should be aesthetically pleasing. You don't want it to be cumbersome and looks ugly. Also, as I mentioned before, there should be little added resistance to the user.
Okay, we looked at some currently available ways in which a bike can generate power. The first one is a pedal launch stationary bike generator. That creates a good amount of electricity, but you're not able to go anywhere with it. The wheels pressed up against the little the generator on the bottom, and that's what powers it. The batteryless bike flashing lights, that uses a magnet, which is on the spokes. It goes around the wheel. It spins a magnet in the little generator down here to create a pulse to flash a light in the front and the back. Those were a couple of the designs we looked at for ways to generate power. We decided that we want a friction wheel that can be either mounted in the front or the back of the bike. And a big problem was we didn't want to add resistance to the bicycle, so we're going to make it able to, you can disengage it when you're going up a hill or something, and re-engage it when you're going down a hill, just to maximize it. And it's going to go, it's going to go through the wires, power your batteries up through cables into your phone and whatnot. It's going to be lightweight, as we were looking for. That was another big concern in the surveys. Weight was a big problem. No one wanted a heavy device, and it'll just have a standard USB port, to plug your phone in, plug your iPod in. Those are all USB powered, and just as Ken said, all the objectives.
Okay, so just to do a basic run through of how the device would work. This is our alpha prototype. First section would be the friction roller. That is a cylindrical roller that will be then this would in turn be connected to the gear train and then and then to the magnetic coil generator. From this part, where it's converted from mechanical into electrical energy, it will be then sent to the battery. Battery will store the charge, and then it can be discharged to plug an iPod or a flashlight or a headlight. These are not to scale. Sorry.
So what's next? So, you know, there's lots of electric components that go into this, obviously. It's not going to be easy, but we are thinking about creating our own circuit board, you know, for the components, because we have to mechanically power the bike, and then like we have to convert that into like electrical energy through like our generation system, and then we have to convert that into usable electrical energy, so we can convert that to like USB docks, and you can plug your apps into that. So that's definitely going to be something to consider. I kind of just touched that too, like the generator's going to have like an electromagnet, so we have to calculate like the wattage and see like, you know, what's usable, what's not, what's practical. Gear train selections, you have to solidify a method of attaching the housing to the bike frame, and obviously we want it to look good. So our challenges, so we want to achieve 15% efficiency in converting mechanical energy to electrical energy. That's pretty plausible, so it's not too big of a challenge. The bike attachment security, you know, it's going to be kind of a nice thing to have on your bike, and you know, people steal bikes, so it's kind of going to add to like bike theft. So we want to make sure it's secure. We want to develop an easy installation method for the average user, so you can like, you know, install it, uninstall it, use it at your leisure. And lastly, we want to just maintain a competitive price, and you know, make it affordable to like the average user and the bike enthusiast too. So it's a broad range of the market. Any questions?
You guys mentioned that you wanted to make it like have minimal added effort to the user. So do you guys try and quantify that at all as a percentage? And then also, did you look at you know, how much energy could be harvested on a 10-minute bike ride kind of thing?
Okay, nice double-sided question. Try to answer I'll answer the second part first. Actually, sorry about that. We basically looked at it, and basic user can generate about 100 watts an hour biking. So let's say like a 30-minute trip, you're going to be doing about 50 watt-hours. So our basic 15% conversion rate came from basic size of an iPhone battery and how much power it takes to fully charge that. So basically, you know, something around the lines of like 7 watt-hours would charge an iPhone battery, 50 watt-hours just from biking, so like a 15% conversion rate. Be successful. Sorry, what was the first part again?
Oh, the additional resistance?
Yeah.
Oh, additional resistance. Well, it's going to be an increased resistance to user, but I mean, in terms of total distance, you know, it's going to be the same amount of distance. So if they do want to charge, there is a chance there will be an increased effort on their part, but we'll try to keep it as low as possible. We will be using friction, though, as our contact, so there will be some increased effort.
In terms of like commercial, other things on the market, like there's like the friction wheel generators too, like for like the headlights. You know, it's just like gearing up a little bit. It's not too much resistance.
One question left.
Will the housing be like weather resistant, like for rain and such?
Right. Well, it's important for the attachment to securely be on the bike and something that they don't have to worry about. So it should just be considered part of the bike. So in that part, like definitely rain and weather, just overall durability will be important factors for us.
Okay, thank you.